Can you prove that two categorical variables are actually related? The chi-square test gives you the statistical evidence. Unlike tests for continuous data, the chi-square test works with counts or frequencies. Imagine rolling a die 60 times. Is it fair, or are the observed counts too different from what we expect? The chi-square test is mainly used for goodness of fit and tests of independence. The formula is chi-square equals the sum of observed minus expected squared divided by the expected count. Larger differences between observed and expected values produce a larger chi-square statistic. The decision also depends on the degrees of freedom and the critical value.
Suppose a fair die is rolled 60 times. The expected count for each face is 10. After calculating the contributions from all 6 faces, the chi-square statistic equals 1.0. Since this is smaller than the critical value, we fail to reject the null hypothesis and conclude that the die appears fair. Now, consider a test of independence. We want to know whether customer satisfaction depends on age group. First, create a contingency table. Define the null and alternative hypotheses, and calculate the expected count for every cell using the row total multiplied by the column total divided by the grand total. Next, compute the chi-square contribution for every cell using observed minus expected squared divided by expected. Summing all the values gives a chi-square statistic of 1.851 with 2 degrees of freedom. Since the statistic is below the critical value, we fail to reject the null hypothesis. The shape of the chi-square distribution changes with the degrees of freedom. As the degrees of freedom increase, the curve becomes wider and shifts to the right. Only values in the right tail beyond the critical value lead us to reject the null hypothesis. A significant p-value tells us that an association exists, but not how strong it is. That's why we use Cramer's V. It measures the strength of association between categorical variables, with values closer to 1 indicating a stronger relationship. Before applying the chi-square test, make sure the observations are independent. The data consists of counts rather than percentages. Expected cell counts are sufficiently large, and categories are mutually exclusive. For very small expected counts, use Fisher's exact test. Standardized residuals can also help identify which cells contribute the most. In Python, use chi-square for goodness of fit, chi2 contingency for tests of independence, and calculate Cramer's V to measure effect size. To recap, the chi-square test compares observed and expected counts, evaluates categorical relationships, and works best when its assumptions are satisfied. Follow the Daily Deploy for more AI, machine learning, and statistics explained visually.